Good morning, students. In this video lecture, we are going to see the construction of the cycloid. Now, the problem given here is draw a cycloid of diameter 50 mm. We are going to draw the cycloidal curve for the diameter of the circle is 50 mm. Okay. So, what is meant by cycloid? So, a circle of diameter 50 is available. A point A is located on this circle. When the circle is rolling on this straight line, when a circle is the point of the circle, the path traced by the point A of a circle, when it is rolls along the straight line, okay, it will generate one curve. For example, when the circle rolls to some extent here, this point will move here. Again, when the circle rolls here, the same point will be available here. Again, when the circle rolls to some extent, the same point may be available here. So, ultimately, after the one full revolution, the path traced by the circle, the path traced by the point A on the circle will generate the curve called as cycloidal curve. So, cycloid means when a circle is rolls on a straight line, the curve generated by the point A will be called as cycloidal curve. So, how to draw the cycloidal curve? That's what we are going to see in this video. Now, to take the compass with the diameter 50 mm. So, the radius of the circle will be equal to 25 mm. So, with the radius 25 mm, you draw the circle. First, locate the circle using horizontal and vertical center line. Now, with the radius of the circle, diameter is 50. So, the radius of the circle will be equal to 25 mm. So, with the radius 25 mm, we are going to draw one circle. Okay. Now, divide this circle into 8 equal parts using protractor. For example, in protractor you are having the intersection points, horizontal and middle and vertical line will be available. That intersection point you are going to keep here on the horizontal center line. So, when you divide the circle into 8 equal parts, 360 degree divided by 8 will be equal to 45 degree. So, mark 45 degree, then 90 degree. So, here 0 is available. So, mark 45 degree. Okay. Now, you keep the scale through the center of the circle and this division point. So, through that you are going to draw the division line. Similarly, keep the pencil on the center of the circle. So, here you mark 45 degree point. So, through that you draw one 45 degree line. Now, we have divided the circle into 8 equal parts. Okay. Now, I am going to mark point A on this rolling circle. since the circle is rolling along clockwise direction. Okay, we are going to give the notation here 1 up to 8 points. We are going to give in anti-clockwise direction. Now through this division point A, you draw one horizontal line. So when the circle is rolling along a straight line, when the circle rolls one full revolution, what will be the length of the line you will be having here? That will be equal to this pi circumference of the length. So pi into 50 will be equal to 157 mm. So from the division point A, you draw 157 mm line length. Okay. Now, since the circle is divided into 8 equal parts, this line also should be divided into 8 equal parts. So how to divide this line into 8 equal parts? So 157 divided by 8 means you will get fractional measurement. It will be difficult to take. So for that, you have to draw one inclined line. How much angle you have to take here? You can take any acute angle. So I am going to take 20-degree inclination. Okay, you can take any measurement, any angular measurement here. So draw one inclined line. If you take 15 degree to 25 degree, diagram will be neat. If you take more than 25 degree, diagram will not be that much neat. So to get the required neatness, you may use around 15 to 25 degree in the diagram. Okay. Now, what will be the length of the line? This line length measurement, you may take any measurement. Okay. Now, this line, it is, you are going to divide this 157 mm into 8 equal parts. That means each division will be approximately equivalent to around 20 mm. Okay. So, for our convenience, you can use 15 mm. At 15 mm interval, you divide this inclined line into 8 equal parts. Okay. Now, after the division here, the distance of this horizontal line will be equal to this pi into diameter, circumference length of the circle. Now you join this last division point with the end point of the baseline. Now move the scale parallel to the last line. Draw the parallel line to the last line available here. Okay. Just move the scale parallelly. You can divide this line into number of equal division. So using this method, you can divide any line into equal number of divisions. Okay. Now for this you can give the notation. The starting point, that is the point A is available here. This is a starting point. So this one will make contact here. After the rotation, this 2 will make contact here. Okay. Then this 3 will make contact here. So you have to give the notation in this order. Now, to draw the diagram in a neater manner, what you have to do is, through the 8th division, through this 8th division, you draw one vertical line. Okay. Then through the division point 4, so that you can draw the diagram in a neater manner. Through the division point 4, draw the horizontal line. Okay. Now, why I am drawn this outer boundary? So that the projector line will not extend beyond this boundary. So you can draw the diagram in a neater manner. Now through this center line of the circle, first you draw the horizontal line. Okay. You draw one horizontal line through the center of the circle. Now what you have to do is, through each and every division point of the baseline, through each and every division point of the baseline, you have to draw the number of vertical lines. So you can use the set square. Okay. Keep the set square scale over this point. So you can use the set square. Using that you can draw the number of perpendicular lines. Keep the set square over the baseline. Now, through the first division point, when you draw the vertical line, okay, it is going to intersect here, forming center point 1. Through the division point, this will be intersecting with the center line. So that will form center point C2. So like that you are having number of center points up to C8. Okay. So this is then through the division point, all the division points, you draw the horizontal lines. Now when you draw the horizontal line here, this 7 and 1, both 7 and 1 will coincide. So I have drawn one horizontal line. Through the 7 and 1, both are coinciding. Similarly, the 5 and 3. So both are coinciding. Okay. Now, you are going to take the measurement C11, that will be radius. C11 will be radius, center point will be C1. With the center point C1, you have to draw the arc on the line passing through this division point 1. For the first half revolution, that is up to the center point 4, you have to draw the arc on the left side. For the remaining half revolution, that is C5, C6, C7 and C8, you have to draw the arc on the right hand side. Okay. So radius will be C11. How much will be the radius C11? That will be equal to radius of the circle. And the center point will be C1. Draw the arc on the horizontal line passing through division point 1. This is a division point 1. You are having one horizontal line. On this horizontal line only you have to construct the arc. Okay. Now, we are going to take the radius of the circle. That is equivalent to C1, 1. So with the center point C1, with the radius of the circle or with the radius C1, 1, both will be equal. Draw the arc on the line passing through division point 1. So I am going to draw the arc on the line passing through division point 1. Similarly, with the center point C2, with the radius of the same radius of the circle, draw the arc on the line passing through this division point 2. Then center point will be C3. With the radius of the circle, draw the arc on the horizontal line passing through C3. Likewise, you have to construct the arc. So with the center point C2, draw the arc on the horizontal line passing through division point 2. Then center point will be C3. Draw the arc on the horizontal line passing through division point 3. Then with the center point C4, draw the arc on the horizontal line passing through 4. Then center point will be C5. How much will be the radius? Radius will be equal to radius of the circle. The center point C5, on which line you are going to draw the arc? Lot of horizontal lines available. On which line you have to draw the arc? When the center point is C5, you have to draw the arc on the horizontal line passing through division point 5. After the fourth division, you have to draw the arc on the right side, not at the left side. Then center point will be C6. Division point 6 is available here. On this line only you have to draw the arc. Then center point will be C7. Division point 7 available here. That is 1 and 7. Both are coinciding. So on this line you just draw the arc. So last point will be here. So for all these points I am going to give the notation. This will be 1 1. For second point 2 1. For third point 3 1. This will be 4 1. 5 1. This will be 6 1. This will be 7 1. Last point will be 8. Now the radius of the circle will be radius will be equal to radius of the circle. That is C1 1, C2 2. Everything will be equal to radius of the circle. Center point will be C1. When you take the center point C1, draw the arc on the horizontal line passing through 1. This is the first arc. When you take the center point C2, draw the arc on the horizontal line passing through division point 2. So this will be your second arc. Likewise, you are going to construct the arc. So center point will be C1, C2, C3 up to C8 are going to construct the arc. Now, the free end, you smoothly connect the curve. Now, how to draw the tangent and normal? In your diagram, only this circle should be dark and the curve, the final curve you have drawn, cycloidal curve, should be dark. All other lines should be very, very light and thin. Now we are going to draw the tangent and normal. Even though in problem they have not asked the tangent and normal, you have to construct the tangent and normal. Now I can select randomly one point, that is point P on the curve. Now you take the radius of the circle. Take the radius of the circle. So with the radius of the circle, through the center point of the point P, you draw the arc on the center line. So what will be the distance here? It will be equivalent to radius of the circle, that is 25 mm. Now through this point you erect one vertical line. That point I can give the notation N. Now join this N with the point P. That will give you the normal. So Mn will be the normal. Now, through the point P, you keep the protractor scale in alignment with the tangent line. Okay. So mark 90 degree to the tangent line. So through this point, we are going to draw the tangent. So if you are having any doubt here, you can ask or clarify your doubts in chat box. Thank you.